Good day, my name is Yevseyevich, and today I'm going to be talking about my research project called Evaluation of Artificial Intelligence Applications in the Assessment of Panoramic Radiographs. And I'm currently a third-year dental student at the Roseman University College of Dental Medicine. I'm going to be going through an overview. My overview includes the background, methods, results, implications, and conclusions of the project. First, through the background. Everybody who has dental caries, a lot of the time, if those caries reach the pulp of the tooth, that person's going to have pain. And so what do dentists do? Dental practitioners, they take a panoramic radiograph to see everything that's going on inside the patient's mouth. And there's been a lot of talk with AI programs recently, and so my group and I decided to develop a project based on how these AI programs are incorporated into the dental world. We asked ourselves the research questions. How can AI models enhance the performance of dental caries diagnosis using panoramic radiographs? And what are the benefits and challenges of integrating AI into other diagnostic process? To start our methods, we first did a database search. We searched PubMed, Scopus, Web of Science, Dentistry, and Oral Sciences sources, and we included until September 2024. With keywords artificial intelligence, machine learning, deep learning, and panoramic radiograph, as well as dental caries. After this, once we did our database search, we made our inclusion and exclusion criteria. And so for the inclusion criteria, we did the article must be focused on panoramic AI in diagnosing dental caries. They must be peer-reviewed full-text original articles, articles written in English, and study involved human subjects. Also, for exclusion criteria, we did articles that are not related to panoramic AI and diagnosing dental caries, conference proceedings, editorials and opinions, articles that provide abstracts, and articles not written in English. We then continued the methods through a study selection process. We made it to 2 stages called title and abstract screening, followed by full text review by 2 independent reviewers on our team. And any discrepancies were resolved through discussion that we had with our team. The data extraction synthesis was next, which we did AI models use, study characteristics, and diagnostic outcomes. Then we synthesized using descriptive analytics to identify common themes, benefits, and limitations. You can see here then we created a chart, which we had enough records identified. Then we did duplicates removed. Then we assessed the remaining records for eligibility. And you see at the end, we indicated to review 9 articles. This is what we came out the results, and we got the everything from the AI articles that we used. And you can see the AI programs are Cranial Catch, CarieSeg, Deep Learning Model, and then DCDNet, 2-typed enhanced transformers, another name known for it, and DagnaCat. And we can see the associated learning models with the AI programs. You can think of it as kind of like a kingdom, where there is a king, which is the AI program, and then the workers underneath the king that help the whole kingdom operate, called the associated learning models. And each AI program has its associated learning model with it for it to work. This is an example of one of the AI programs and how it was utilized. We can see here that there was an input of a panoramic radiograph into the AI program. Then the associated learning models took the took the panoramic radiograph and then highlighted the radiolucent areas that are on the teeth. Then, after all those associated learning models were finished, they produced an output of the same panoramic radiograph with the identified areas that there could be caries. And we can see here that there was the original radiograph, then what the AI predicted the teeth look like, and the third is the radiograph of the actual panoramic. This was an AI program that was utilized called 2-type enhanced transformer, and we can see that under a second, it identified an accuracy of 95% of all the caries later that were looked at by the dentist. And we can see there that there was a type 1 occlusal caries, type 2 proximal caries, and a type 3 cervical caries that were all identified by the associated learning models in the AI program. We gather all of the AI articles and so there was 9 of them, as discussed before in the methods. We had the associate AI programs, and then our team, we took specific performance metrics of specificity, accuracy, and F1 scores. And then we also indicated the number of radiographs with each article. This is kind of the meat and greet of the whole project right here. We have the names of the AI, and then as you can see, some of the values, like for the deep learning model, we can see how high the specificity is with 0.94, which is almost like 94% pretty much. It had an accuracy of an average of 97%, and it had an average of 92% F1 scores with all the AI, with all the panoramic radiographs that were sent and recorded with the AI. This is our discussion. So we had the deep learning model boosted the highest average values. DynaCAT showed a higher level of reliability. The two-type enhanced transformer presented with reliable diagnostic capability. The CranioCache displayed basic moderate capabilities. And lastly, the DCD-net demonstrated lowest performances, but the carrier seg exhibited less than moderate tendencies. This is kind of how we can utilize this whole project and how are these AI programs utilized in a dental world. And I found this super interesting with my team. So we had 2 dentists that were given over 8 radiographs, and then they were told to try to identify all the type 1, type 2, and type 3 caries in these panoramic radiographs, and they were given about a minute to do so. And we can see that the average time for these 2 dentists was around 64 seconds, where they said that they were sure that they got everything in the panoramic radiograph for both of these. And we can see then that the dentist had an average accuracy of 88%, which is pretty good, and an average precision of 85% of all the caries that were actually present in the patient's mouth. We can see then with the AI had an average accuracy of 92, an average precision of 87, and an average F1 score of around 90%, with an average time of under a second. And so in conclusion, in comparing AI models for dental diagnostics, the deep learning model excels, while DynaCAT and TTET showed strong performances. And then Kerosene and CranioCache were moderately effective, with DCD-net being the least reliable. Despite the potential AI models face limitations due to having the panoramic radiographs be submitted in really good quality, if there's any overlapping structures, they're just going to be less effective, and they have to be in higher resolution. So that's something that the assistants or the dentists will have to make sure they upload correctly. Thank you for enjoying my project, and hope everyone has an amazing day.